Welcome to The Explainer. Today, we're diving into how a really old industry, we're talking insurance, is using some seriously new tech to answer billion-dollar questions about worst-case scenarios. We're talking about massive natural catastrophes and how machine learning is completely changing the game when it comes to predicting the unpredictable.
So to really get why this technology is such a big deal, you first have to understand the sheer scale of the challenge we're talking about. We're modeling catastrophic events for an entire industry that, well, absolutely depends on getting these predictions right.
I mean, this is it, right? This is the core question that catastrophe modelers have been wrestling with for decades. They're not just trying to figure out if it's going to rain tomorrow. No, they're trying to model the financial fallout of these massive rare events like monster hurricanes and epic floods that are just, by their very nature, incredibly complex. For the longest time, the approach was pretty traditional, based on physics and statistics we already understood, using rules someone programmed in. And it works, but it's always limited by our own assumptions. Machine learning, though, it flips the script entirely. It learns directly from huge piles of data to find these hidden connections, things a human might never even think to look for. So let's get into it. What exactly is this new tool, machine learning? It's a phrase that gets thrown around all the time, but what's it really doing here? Well, it all starts with this bigger concept, artificial intelligence, or AI. And believe it or not, this idea has been around since the 1950s. It's just that now, with all the computing power we have, it's finally taking off. The whole point is to make machines that can think and act smart, which in our case means learning to see these incredibly complex events coming. Okay, so if AI is the whole field, machine learning, or ML, is where the magic really happens today. And here's the crucial difference. You don't give it a strict set of rules. Instead, you just feed it data, tons of data, and the algorithm learns on its own. It's basically teaching itself, which means it can make predictions it was never, ever specifically programmed to make. This quote from the Brookings Institution just nails it. These systems don't just spot patterns. They learn to make intentional and intelligent decisions. I mean, think about that. That's a massive leap from just following a pre-written script. So let's see what that looks like in the real world. All right, enough theory. Let's look at our first case study. Teaching a machine to predict something as wild and complex as the rainfall from a hurricane, or what the meteorologists call a tropical cyclone. So here's the massive hurdle. To really understand the risk, you need to simulate, well, a lot of storms. We're talking tens of thousands of seasons worth. But trying to run detailed weather models for that many scenarios on normal computers would take pretty much forever. It's just not practical. The solution they came up with is just brilliant. First, they built a dictionary of thousands of rainfall patterns from actual historical storms. Then they trained the ML model to look at a new storm, figure out its personality, its speed and intensity, and then it just picks the right patterns from that dictionary, stitching them together like a quilt to build a brand new, totally realistic storm from scratch. And the result? It's incredible. Not only is it super fast, they can crunch through 100,000 seasons in just a few weeks, but the final simulation is so good, you literally can't tell the difference between it and a high-resolution weather forecast. Okay, so that was hurricanes. Next up, we're going to see how that same kind of smart thinking can be used for a totally different problem, figuring out flood risk by predicting how these huge reservoirs and dams are going to react when it pours. Now, the big challenge here is that every single reservoir is different. The rules an operator uses to release water can change all the time, depending on what the dam is for. Is it for power, irrigation, flood control? So you can't just build one generic model and call it a day. It would never work. So what did they do? Well, this is super cool. They trained a unique AI, an artificial neural network, for every single one of the 412 reservoirs in their study. It's like giving each dam its own custom brain. And they did something really clever. They actually taught the model to look at future weather forecasts, just like a human operator would, so it could plan ahead. And did it work? Oh, yeah. When they put these models to the test against almost 4 decades of real-world history, the AI's predictions were spot on. It had actually learned the unique personality of every single dam. Okay, for our final case study, we're shifting gears completely. We're going from weather to buildings. We're going to see how machine learning can be used to literally map out risk by finding specific buildings from outer space. So picture this. You need to find every single high-rise building in a massive country, but you've got no reliable data. Asking a team of people to scan satellite photos of every city, every town, it would be an absolutely impossible job. So, the solution is to teach an algorithm to see like a person. They used a special type of AI that's amazing with images. It's called a convolutional neural network. They trained it to spot the telltale signs of a high rise from above. Things like the long shadows they cast, their specific shapes, the way they cluster together. And here's the brilliant part. The AI doesn't have to be perfect. Its job is to turn that impossible task into a manageable one. It scans the whole country and spits out a short list of places that probably have high rises. That lets a human expert come in and efficiently review a much smaller, targeted list. The machine does all the heavy lifting.
All right, let's pull all this together. We've seen machines build hurricanes, predict how reservoirs will behave, and find skyscrapers from space. What does all this actually mean for the future of forecasting risk?
Well, the biggest takeaway is this. Machine learning isn't some magic wand, it's an incredibly powerful but complex tool. The real magic happens when you pair the algorithm with deep human expertise. It lets us move from models based on what we think should happen to models that learn from what the data actually shows us. It's unlocking insights that were just out of reach before. And it's not just for natural disasters anymore, it's quickly moving into things like cybersecurity and life risk. And that kind of leaves us with one last big thought. We've just seen machines learn to model some of the most complex things on Earth. It really makes you wonder, if they can learn to predict a catastrophe, what's the next impossible problem they're going to solve? One thing's for sure, we are just scratching the surface of what these learning machines can do.